Since I have read these questions earlier, let us start with the last question so that when you people start, you will start with the first question without seeing the answer. So I'll start with the last question, that is, what percentage of kinetic energy of a moving particle is imparted to a stationary particle when it strikes 9 times its mass, suppose, and equal to its mass and 1/9 of its mass. So the solution is to this question is question number 30 solution we are doing. We are saying that there is a mass m1 is say m and m2 is some x times m1. It could be x. If x is 9, then it is 9 times of this. If it is 1, then it is equal to, and if it is 1 by 9, then that's why I've taken m2 in this manner. Now the point is, we know that what percentage of the kinetic energy is imparted to a stationary particle. That means u1 has some velocity. We don't know where u1 exists. u1 is there. u1 is say u, and u2 is 0. Very simple, because it is at rest. Now, what percentage of kinetic energy of the moving particle is imparted to the stationary particle? The stationary particle. So now you have got v2. The expression of v2, we know that from our earlier discussion, is 2m1 u1. For perfectly elastic collisions we are talking, m1 minus m2 u2 upon m1 plus m2, and v1 and v1 this is stationary particle when it strikes. That's the point. Now it is saying how much kinetic energy has been transferred from this to that. That is the thing. So when I put the value of u2 and u, I get, and m2, m1 and m2, I get this as, so v2 becomes 2m u upon m1 is m and m2 is xm. So I get 2, I take mu upon m common, 1 plus x, n and m cancels out. I get v2 equal to 2u upon 1 plus x. This is what is there. They are asking you the percentage transfer of energy on the second particle by the first particle. By the first particle, what is the transfer of energy? The kinetic energy after collision, right? After collision is, now if you want to understand v1 also, you may ask what about v1. So v1 is your m1 minus m2 u1 plus 2m m2 u2 upon m1 plus m2. So this is 0, and this is u2, this, sorry, m1, this u2 is 0. Sorry, this u2 is 0, not this is 0, but u2 is 0. Wait, your u2 is 0. So your v1, let me write this here. So v1 comes out to be, let me do it with a different color. Wait. So v1 comes out to be your 2xm this comes out to be, wait a minute, this comes out to be m1 is m common, 1 minus x u1, that is u, upon m common, 1 plus x. So m cancels out, you get v1 as this. This is v1. Now if this is v1, now they are asking you the transfer, what percentage of kinetic energy of the moving particle is imparted to the particle when it is at rest. Now v1 is the velocity of the first particle. I'm not interested in this velocity. Let me shift it somewhere up a little bit. Wait a minute. Let me shift it here. Wait. Just a minute. Here, let me shift it here. Yes, now it's okay. Now this I'm not interested in. This particle I'm not interested in at all. because I want to see this is the velocity of the second particle after collision. This is the velocity of the first particle. See, this is the velocity of the first particle after collision. This is the velocity of the second particle after collision. Fine, I want to see what is the percentage transfer of energy. That is the kinetic energy. You know, in initial upon final, you have read this type of formulas. Profit upon cost price into 100 gives you the profit percent in smaller classes. This is the same type of problem, like that only. Not like that, but somewhat like that. You can take the percentage of kinetic energy transferred, percentage of kinetic energy transferred, whatever the case may be. Kinetic energy transferred is a kinetic energy of the second body, kinetic energy of second body, second ball or body, whatever you say, upon mass body, whatever, kinetic energy of the first body. Now let us write it down. Let us write it down. See what happens. This is equal to half. So your kinetic energy of the second particle is half m2. M2 means xm. Xm. Let me write. M2 means xm. M2 means xm. What is the velocity? This is the velocity. So 2u 1 plus x whole square upon your 1 half m u square into 100. This will give me the percentage. As see, m and m will go, half and half will go, and then what you are left with? You are left with 4 u square 1 plus x square whole square into u square into 100. So this u square cancels out. What you are left with now, you are left with x is also on the top. 4x upon 1 plus x into 100. Now 100. Now for the first case, case number 1. Case number 1 is, if m2 is 9 times, that is m1, that is implies, this is the first case, x is equal to 9. Just put the percentage of kinetic energy. Percentage of kinetic energy is now 4 into 9 upon 10 into 100. That is, this is around 9 whole square. It is whole square. 10 whole square, 10 into 10. So they all go out. This comes out with 36%. I forgot this whole square here. Let me rewrite this clearly. This becomes 1 plus x whole square. This whole square I forgot here. The whole square I forgot this whole square. Now, if it is, now the next part is, if it is equal to the mass. Suppose now x is equal to 1. Second case. X now m2 is equal to m1 implies x is equal to 1. This was 9. X is equal to 1. Then percentage change in kinetic energy is 4 into 1, and this is 1 plus 1 2. That is 4. 1 plus 1 2. That is 2 square. It is, see, 1 plus 1 and on the whole square, that is 2. 2 square is 4 into 100, and this gives you total 100%. 100%. The third case is if it is 1/9 time. Third, m2 is 1/9 of m1. That means x is 1 upon 9. So 1 upon 9. So percentage of kinetic energy is 4 by 9. 4 by 9. Let me rewrite. 4 by 9. 4 by 9. 4 by 9 into 1 plus 1 by 9 whole square into 100. That makes 4 by 9 into 10 square into 9 square into 100. This 100 and this 100 goes out, and this 9 and this 9 goes out, and you get 36%. This is 36, 100 and 36%. Wait, you get this much. Yes, this is question number 12, I hope so. Yes, we are going in the opposite direction. Exactly. Now there is a mass m1. The ball's mass is 2 kg. No problem. M2 is of 10 kg. M2 is of 10 kg exactly. U1 is of your 10 meters. Let's write it 10 meters per second. I cap eastward. Eastward I'm taking as eastward I'm taking as positive I. This is what I'm taking as, making you understand. Now u2 is minus west is minus east, that is minus 4 meter per second I cap. Now either I use that same long equation, or what I can do is that, see the trick, let me rub this. Let me rub all this. Now the thing is that what I can do is that I can take, see when I write V1, I will write when I write V1, I'll write M1 minus M2 U1 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 plus 2 M1 U2 plus 2 M2 U2, sorry, 2 M2 U2 upon M1 plus M2. And when I write V for V2, I will write, see, I'll write 2 M2 2 M1 U1 plus M2 minus M1 U2 upon M1 plus M2. This is the way I write basically. And since the direction has been changed, because this is eastward and this is westward and this is the negative sign, do one thing, this is U2, this is U1. We can do one thing, straight away use the scalar form. Just keep in mind, whichever direction has been changed, put in that a minus sign and then you do the thing. मतलब जिसका डायरेक्शन चेंज हो गया है, जैसे यहाँ पे दिया है इन्होंने ये वेस्टवर्ड मीन माइनस ईस्ट, दैट्स व्हाट आई हैव रिटन. वेस्टवर्ड मीन्स माइनस ईस्ट, दैट्स व्हाई दिस माइनस ईस्ट इज हियर. नाउ जहां पे भी माइनस दिखेगा वहां पे बस जिसके लिए माइनस है वहां पे माइनस पुट कर देना, दैट्स ऑल. लेट्स देखो कैसे, लेट्स सी हाउ. V1 is equal to, what is this, 2 kgs, 2 minus 10 into U1 is 10, no problem. 2 U2 M2 is 10 and you have minus 4. You have minus 4, no problem. Now upon this you have 10 plus 2. Now in this case you have V2 is equal to 2M1, 2 into 2, this is minus U1 is 10, no problem. And M2 is 10 minus 2 into minus 4. What is that? The direction has been changed, so I took the minus sign along with it. I took the minus sign, to avoid lot of calculations. Just remember this formula and put a minus sign wherever necessary. जब direction change होगा, when the direction changes, then put a minus sign there. The direction of the velocity which changes. अगर suppose this was also positive, then you would have taken positive, no problem. And then 10 plus 2. Now you have straight away calculations now. See, straight calculations. Straight calculations, we will drag it down. So this becomes minus 8 into 10, minus 8 into 10 plus minus 8 again into 10, and we have 12. So this becomes, and this becomes 4. V2 becomes 40, and this is 8 and minus 32 by 12. So this V1 comes out to be minus of something 80, 160 by 12, and this comes out to be minus 13.33 meter per second, and that means it is going westward. East is plus, and because see, one thing, very simple. We have taken the west to be minus. Just see, this west is, sorry. Just a minute. Yes. This is the complete your west. West has been taken as a minus sign. You can see this minus sign. So whenever you see a minus sign in the answer, that means it's going westward. जब भी माइनस साइन दिखेगा, जो डायरेक्शन ऑपोजिट वाला डायरेक्शन है उस ऑपोजिट वाले डायरेक्शन पे जा रहा है. जैसे ये वेस्ट पे जा रहा था इसलिए माइनस साइन लिया है. अब यहाँ पे ये माइनस साइन आया है, यहाँ पे ये माइनस साइन आया है, तो इसलिए ये अब वेस्ट पे जा रहा है. इट्स गोइंग वेस्टवर्ड. दिस इज गोइंग वेस्टवर्ड. V1 is westward, no problem. Westward, no problem. Now what about V2? V2 is coming out to be 8 by 12 meter per second, and this comes out to be about 0.67. You can use the calculator. You are supposed to use scientific calculator, and this is eastward. Write down eastward because it is positive sign. It is eastward. This is westward. This is west. Now the thing is, you have to find coefficient of restitution. The part is the coefficient of restitution. Coefficient of restitution E. E is, it is, I have already told you the formula. You can see here. Wait a minute, for your remembrance, I'm taking you there only, very simply. I'm taking you very much there. See, I'm taking you very much there. Yeah, just a minute. Let me pull it little bit down. Yes, you can see V1 minus V2 upon U2 minus U1. So let's come down quickly. Let's come down quickly to this point. Yes, let's come down. Yes, see V1. V1 is minus 13.3 and minus V2. V2 is what? 0.67. Now, what you have is, now what is U2? U2 is in which direction? This is V1 minus V2 and U2 minus U1. U1, your, that is minus, U1 is minus 4 and minus 10. So this all comes out to be around 13.9. No, wait a minute. Let me do the calculation properly. This is, wait a minute. Or I can leave it for you also if you want. This is 0. This is now 7070 and no, 1. 0 and 1 it is. Sorry, it is 1.41 upon 14. So it is coming out to be wrong somewhere because this has to be less than 1 and greater than 0. Somewhere something has gone trivially wrong. Wait a minute. Mm, it is V1 velocity of separation by velocity of approach. Let me recheck the formula. Just a minute. Let's recheck. Let's recheck the formula. Let's recheck the formula once more. Wait a minute. Here it is. Yes, velocity of separation by velocity of approach. Yes, this is minus of this and this is U2 minus U1. Exactly. I have done the right thing. Then why is it coming out to be wrong? Let's recheck the calculation. This is eastward, right? Yes, I'm taking plus I in this direction and this is minus I. Fine. This is V1 minus V2 upon U2 minus U1. U2 is how much? U2 is minus 4 and minus 10. So have I done the calculation somewhere wrong? See, 0, 7, again a 0, again, oh, that's right. We are right. I did a mistake. I did a mistake. This is, calculation was wrong. Calculation was wrong. 0. So it came out to be 1. So when E comes out to be 1, it's perfectly elastic. Perfectly elastic. Perfectly elastic. Elastic. Just check it once more. I think I'm right. Yes. Now the next is, see, let me write down the formula for you here. Let's write down the formula for you. E is V1 vector minus V2 vector upon U2 vector minus U1 vector. You should always remember this. This is the point. Now the next question, let us see which is the next question. Let us see the next question very quickly. Here it is, here it is, here it is, here it is. Yes, a ball of mass, question number 11, a ball of mass m is rising with an acceleration is to show that the fraction of the weight that you must throw out in order to double its acceleration is this. That means ये बोल रहा है कि कितना मास मुझे फेंक देना है, पहले acceleration ए से जा रहा था, अब कितना फेंक देने से वो 2a से जाएगा, कितना मास मैं बाहर फेंक दूं इस बलून से, क्योंकि वो 2a से ऊपर जाएगा. I mean to say, how much mass need I throw out of this balloon so that earlier it was going with an acceleration a, now it has to go with acceleration 2a, double. You can see the word double, 2a, that's the main thing. So let's see how to do this problem. Let's see how to do this problem. Now the concept is here. Let me drag a little bit more. No problem. Question number 11. Question number 11. This is my balloon. This has a mass mg. This is the reaction of the air, and this is going with an acceleration a. So r minus mg is equal to m. Oh, let me write it here. We'll waste a lot of space. Let me write it here. R minus mg is equal to ma. I think I took capital M. Let me take capital M. Sorry. Let me take capital M. I took capital M. Mg, Mg, Ma. So R comes out to be M, A plus G, G plus A. Now this is the point. Now, how much of the mass should I throw out? Should I throw out so that I get this? I get double the acceleration. They are saying how much of the mass should I throw out so that I get double the acceleration. Now the point is how to do apply that part. See, now let us take, yes, now let us take the second case, which is very important. How much of the mass should I throw out? So that now see the mass decrease in mass. Decrease in mass is earlier the mass was m. Now I am throwing out m dash mass. So this is the left mass in the balloon. See, बात सुनो, जो मास मैंने फेंक दिया ये m डैश मैंने फेंक दिया, अब इतने मास से तो जाएगा ना वो ऊपर, डेल m मास से ऊपर जाएगा ये, तो r माइनस डेल m g is equal to del m a. The point is, what I'm trying to say, how much of this, how much of, wait a minute, how much of m dash should be how much this much of mass should be thrown. ये m dash कितना मास निकाल देना पड़ेगा, जैसे कि ये 2a से जाए, 2a. So when I'm making a mistake, it is 2a. Now we should go with acceleration 2a. This is the point. Now the point is, write r equal to del m g plus 2a. G plus 2a. Now r is this and r is this. Though equate both the equation, you will get a del m. Once you get del m, you will get m dash. You will get m dash. You need to find m dash. Now from here, नहीं समझ में आया? एक second बता. Let me make you explain it once more. Yeah, this is saying first balloon is going with some acceleration. This equation I hope you know very very well now using that. Now they are saying how much of the mass should I throw out? This much mass I will throw out. This much of mass I will throw out, so that I will travel with this much of mass and my acceleration will be, now see, my acceleration will be 2a. मतलब मैं कितना मास मैं बाहर फेंक दूं, ये मास कितना होना चाहिए जो बाहर फेंकना पड़ेगा, उसका जो बाकी बाकी रहेगा वो तो ये रहेगा ना, बाकी जो रहेगा उससे तो मैं अब उस पे लगेगा ना, अब ये इक्वेशन, ये वाला इक्वेशन, ये वाला इक्वेशन अब तो इस पर लगेगा ना. अब एक्सेलरेशन क्या हो जाएगा 2a. तो नाउ डेल m 2a. अब ये r और दिस r एंड दिस r इज सेम. From this you calculate m dash. That's what it is. Now see. Now one you have m g plus ma. That is the previous equation. Now from here you have m minus m dash g plus 2a. Now multiply multiply simple multiplication. mg plus 2ma minus m dash g plus 2a. G plus 2a. I need this in the denominator. I did not open this. Now see, mg cancels out, goes there and cancels out. Now see, ma minus 2ma is equal to minus m dash g plus 2a. Now this is minus ma is equal to m dash minus m dash g plus 2a. This minus and this minus will cancel out. So this will give me m dash is equal to ma by g plus 2a, and this I wanted, and this is what I wanted. I hope you understood. Now the next part, next question is, I think, yes, here it is. A body of mass 2 kg initially at rest under the action of applied force of 7 Newton on a table. The coefficient of friction is 0.1. Hence calculate the work done by the force, right? And then you need to find out all this. Let's do it. Let us do this question. It is saying we have this 2 kg mass. Let us write down what all is given. 2 kg mass at rest it is. Okay, no problem. At rest the initial velocity is 0 and it is under 7 Newton force. The question number, which one it is, 11 or 12? I think 10. Let me check. Oh, it's too fast. Wait a minute. It is, I think, question number 10. It is question number 10. See, question number 10. We are doing question number 10 now. See, very simple. Question number 10. Now they are saying mass is 2 kg. Now mass is 2 kg. Your initial velocity is 0. The force applied is 7 newtons. Now see, they have also given coefficient of friction is 0.1. And time they have given you to be 10 seconds for all of them. Now they are asking you work done by the applied force. Now you know always when a body is here, a force is acting on the body. There is a friction on the table and there is a mass mg, and you know this is the normal reaction. This is Newton and this is normal reaction. Okay, no problem. Don't confuse with the symbols. Or you may write R, or you can write R, whatever you feel like. That's your choice. Now your this is n equal to mu mg. So mu is how much? 0.1. M is how much? 2. And G you take as a 10. So this comes out to be around 2. And then this comes out to be 2 Newton. Some people may use 9.8 and then they will get something near about 2. No problem. Now they are asking you, work done. Now the thing is work done by the applied force. Now the thing is this work done. That means I do not have two things. I do not have two things. This is the normal reaction, no problem. Sorry. This is the friction. This is friction. Sorry, I made a mistake. This is friction. This is friction, frictional force. And N equal to mg. Sorry, I made that mistake. No problem. Now the thing is, I need to know the acceleration. See, I need to know work done. Work done means F into the S. Do I have S anywhere? मेरे पास S कहीं नहीं है. Distance कितना travel किया वो निकालना है S. So now you see acceleration. What is the acceleration of the body? Acceleration is F minus C. Use the equation. Use this two equation. See, you know how to use the equation. Wait, I'll show you. F minus F is equal to ma. So F is how much? That is 7 newtons, and we found out this to be 2 newtons, and m is how much? 2. So you have A is equal to, so this gives you A equal to 5 by 2 meter per second square. Now I want the distance traveled. S is equal to initial velocity is ut plus half at square. I know this formula. Now I'll get the distance. I'll get the distance traveled. Once I get the distance traveled, everything is very simple for me. Now the distance traveled is S. S is equal to 0 into t. T is 10 seconds plus half. A is 5 into 2 into 10 into 10. So 2 5s are 2 5s are, and this comes out to be around 5 5 5s are 25, 25 5s are 125. Yes, 125. Now this is meters. Now let us try to find out the work done by friction. By friction, now this has all been done in 10 seconds. This much is the distance traveled in 10 seconds, and the work will now be work done. It will be now by first part. Work done by force. Force is how much? Force is 7. 7 into 125. And this will be around 7 5s are 35. 7 2s are 14. 17. 7 5s are 35. 3 2s are 14. 7 7 1s are 7. 8 875 joules, something like that. Second, work done by friction. How much is friction? Work done by friction. So this will be minus, because the distance is going in this sense. It is going in this sense, and the friction is in this direction. Friction and the distance is in this, are opposite to each other. So this will be, let's rub this out now. Rub this out now, and we will get, see how much. We will get this equal to minus. What is the friction? Friction is coming out to be 2, and the distance is coming out to be 125. That is equal to 125. That is nothing but 250. 2 minus 250 joules. Minus 250 joules. Wait a minute, let me write it clearly. Minus 250 joules. Minus 250 joules. This is one done. Third. Third is work done by the net force. Work done by the net force means F minus F. They are asking dot S. Actually, this is what they are asking. The net force. Work done by the net force. Now, what is the work done by the net force? F minus F is how much? F minus F is 5 and 125. This is around 625 joules. This is positive because F is greater than small f. Now they are asking change in kinetic energy. What they are asking? They are asking now change in kinetic energy. Now see, change in kinetic energy is earlier. What was the earlier? It was 0. See, it was 0 here. It was 0 here. Wait a minute. It was 0 here. Now the velocity is how much? You need to find the velocity now. See, what is the final velocity? Fourth is V is equal to U plus AT. Use this equation. U is 0. A I think is 5 by 2 and 10 is 10. So you get it around 5 and this is 25 meter per second is the final velocity. Now they are asking you change in kinetic energy. Change in kinetic energy is half mv square minus half mu square. Now m is what? 2 and v square is how much? 25 square and minus half m is 2, mass is 2 and initial velocity is 0. So you get is 2 cancels out. You get 20. This is all 0. 25 square minus 0 and you get 625 joules. This is also in joules. That is the way you do the problem. This problem is over. Next problem. Wait a minute. Next problem. This is question number 10. I think we finished. Now question number 9. A force of this is to be done with question number 9. You do it yourself. I'll just give you the hint. Enough of questions I've been doing. Now question number 9 is W is equal to F dot S. Now whatever I'm saying, see, suppose whatever the F1 I cap, wait a minute, F2 F1 I cap, F2 J cap, F3 K cap. Now you know how to do dot product. That I'm not going to do. And you have S, I think whatever it is, S1 I cap, S2 J cap, and S3 K cap, whatever the value. See, F1, F2, F3 and S1, S2, S3 are the values. F1, F2, F3 and S1, S2, S2 numerical values होते हैं. Just do dot product. That is F1, S1 plus F2, S2 plus F3, S3. Do it yourself. Do it yourself. This you can do it very easily. Homework. This you can do it easily. Next, question number 8. Question number 8. I give you the hint. Do it yourself now. Question number 8. Question number 8 is two simultaneously cars mounted accidents. Two simultaneous accidents to stimulate car accidents. Auto manufacturers put a spring. Put a spring so that yes, we are doing this problem to stimulate a car accident. Auto manufacturers put a spring so that your where am I? With mounted spring of different spring constant, considered typical with a car of mass m moving at 18 km per hour on a smooth. See, everything in its meter now. First kilometer per hour must be converted into meter per second. That is very important. See how to do this. See how to do this. Rest you will do it yourself. This is question number 8, 9, 8. Yes. Question number 8. Question number 8. They are saying m is given to be 1000 kgs. That is around mass of the car, and spring constant k is given out to be 6.25 into 10 to the power of 3 Newton per meter. Now they are asking you the velocity is 18 kilometer per second, 18 kilometer per hour. So this is when it will convert into 18 kilometer per second, you have to do 5 by 18 multiplication. And from meter per second, you have to do 18 by 5 multiplication. So now this will be 5 meter per second, no problem in this. Now, when the kinetic energy of the car is converted to conservation of energy, by conservation of energy, CE, the kinetic energy of the car will become potential energy of the spring. So you know half mv square is equal to half kx square. So how much of this? See, half of cancels out. Your m is around 1000. Acha, velocity is 5 into 5 and k is 6.25 into 10 to the power of 3, and you have x square. Find x yourself. Find x yourself. Find x. What is x? I'm not telling you. And this is in meters. Keep it in this. Question number 8 is done. Now question number 9. Sorry, question number 7. I'm going the opposite way. Question number 7. Question number 7 is a 10 kg ball and a 20 kg ball approach each other with a velocity of 2 meter per second. What are the velocity after collision if the collision is perfectly elastic? Should I do this problem? No, I shouldn't do this problem. I have done this type of problem. This one. Eastward and westward. Do it yourself. You now know the concept. I can give you. Do it yourself. No more of this. Now question number 5. I think, yes, no, not question number 5. It is question number 6. Sorry. Question number Just a minute, let me write down for you. At least question number 7 is somewhat very similar. Question number, and then you have to show that the elasticity is just, it's perfectly elastic. You show the coefficient of restitution E is 1 actually. That's the point. Perfectly elastic. The way I did question number, this one, 12. Exactly this way you have to do it. Now it's I and J. Same thing. I and minus I. Question number, this is, I think, question number, wait a minute, which is this question? Wait a minute. This is question number 8. Now that's question number 7 is same as question number 12. Question number 7 is same as, I'm writing down. Question number 7 is same as question number 12. Do it yourself. Do yourself. Do yourself. Do yourself. This is the thing. Now the next. Now the next one. Let's see which one. Now which one it is. Now I think. Oh, sorry, I got to go. Went very fast. Wait a minute. Yes. Question number 7 is done. Yes. Now, 6. Now, question number 6 we'll have to take. A man fires 60 bullets per minute with a velocity of 70. If each bullet has the mass of 50 gram, find the power developed. Now, this is on power. Very simple. Let's come down. Question number 6. Yes. Question number 7 is same as question number 6. I wrote here. Question number 6. Question number 6 is very simple. Mass of the bullet is 50 grams. That you must convert into kgs. That is 0, 1 by 220. 20 kg. 1 by 20 kg. Very simple. Now they are going at mass of the bullet per minute. 60 bullets per minute. If each bullet has a mass of the bullets. Okay. Per minute. Machine gun fires 60 bullets per minute. That's right. Time is equal to, per minute means 60 seconds. Now this is 50 has a mass, each bullet has a mass of 50 grams. Fine. The velocity is coming out to be 700 meters per second. Very nice. Now what is power? Power is work upon time, undoubtedly. But here work will be same as kinetic, because the work is completely converted to kinetic energy upon time. So this will be half mv square. This will be half m. What is m? M is 1 by 20 again. V square, that is 700 into 700 upon time is how much? 60. This will give me watt. Now this calculation you can do on your own. Half m v square, because mass of the bullet is fired 60 bullets. Oh, they fired 60 bullet also. So the total mass fired is, the total mass, let me write this. So the total power would be, this is power for a single bullet. This is the power for a single bullet. Now the power for the whole gun, I must say, yes, I didn't read the question correctly. Mass was 60 bullets. So the mass of the 60 bullets would be into 60. You must do this here. Into 60. So into 60 it will be here. I forgot. This has to be into 60 because you are taking the mass. This is the mass for single. This was the mass of single bullet. Now there are 60 bullets been fired. So this comes out to be 3 kg. So now you can erase this portion. You can erase this portion and write just 3. And you can do the calculation. Do it yourself. Now the next one, question number 5. Let us see question number 5. Let us see question number 5. Question number 5. 5. Yes, this is 5. A man climbs a staircase. Climbs a staircase of a building. This one, 20 kg on his head, has 20 steps at 2 meters. If it takes 10 seconds, find his power. Again on power. Now, what is all is given? Let us see. Question number 5. No, wait. This is question number 5. Wait a minute. Oh, wait a minute. Yes, question number 5 it is. Exactly, question number 5. Question number 5. Exactly. Question number 5 I'm talking about. This is question number 5. Question number 5. Now see one thing. Question number 5 says, now what is the total mass? See, he's having a 60 kg on his head and a 20 kg. 20 kg, 60 is his mass, 20 is his mass. Total is 80 kgs. 80. Oh, sorry. This is 80 kgs. Total is 80 kgs. Total is 80 kgs. 80 kg. Now, the stair has a height of what is there are 20 stairs. See, one stair has a height of 0.2 meter. So 20 stairs will have a height of 0.2 into 20, that is nothing but 4 meter. So height is 4 meter. This is your 4 meter. Gravity you take as 10 meters per second square, and your time is taking as 10 seconds. Here power is work by time, and here it will be potential energy gained by time. And what is potential energy? mgh by time. What is m? It's 80, g 10, h 4, and this is the next is 10 seconds, and this is in watt. Calculate yourself. I'm not doing it. This you can do the multiplication calculation yourself. Now the next question, that is question number 4. What is question number 4? Oh, wait a minute, sorry, I went too fast. Question number 4. A pump on the ground can pump water to a volume of 30 meters in 15 minutes. If it takes 40 meters above the ground, if the tank is, and the efficiency of the pump, I need to find that. See, mass of the water. I know that it is filling this volume. So I need the mass. I need the mass of the water that has been raised up in the tank. कितना mass? मुझे volume मालूम है, मुझे mass नहीं मालूम. तो मुझे क्या करना है? क्वेश्चन नंबर कौन सा है ये? क्वेश्चन नंबर wait a minute, it's going very fast. Question number 4 it is. Question number 4. Yes, question number 4 it is. See, question number 4 it is saying mass is volume into density. Volume into density. So mass is, volume is how much? Volume is, they are saying 30, and density of water is 1000 gram per cc. This is cc, centimeter. This is meter cube. This is meter cube, 30 meter cube, and this is 1000 kg per meter cube. So this becomes 3 into 10 to the power of 4 kg. This much of water has been taken up. Now output, so power. Output power. Now you need output power. What is output power? mgh. M is this. Mg, height, you know, height is how much? 40. Height is given to be 40 meters off the ground. And this is mgh by time. Time is 15 minutes. Time, okay. The time they have given 15 minutes, converted into seconds. Right. So time, this is equal to, I'm not doing the calculation, 3 into 10 to the power of 4 into 10 into 40 upon 15 into 60, and this is in watt. This is the output power, find it. This is the output power. Now efficiency is, efficiency, I'm just giving you hints. This is equal to output power by input power, input power into 100. Sorry, input power into 100. So this is already given to you. What all is given to you? This is 30. You write 30 here. You write this, whatever value you find, you write it here. And find input power. I'm not going to do it. Do it yourself. Fine. Now the next question. This is question number 4. Question number 3 now. Question number 3. Yes, here it is. A little slowly. Yes, here it is. Yes, a short traveling at a rate of 100 meters per second is just able to pierce a plank of 4 centimeter. What is the velocity required to just pierce a plank of 9 centimeter? What is the velocity required to, this is the thing. Let's go back to question. Let's see what it is saying. Let's see what all is given to me. Question number 2, they are saying the velocity of the bullet is 100 meter per second. It is, the piercing means the height it is, the distance it is traveling is 4 centimeter. Okay. How much should be the velocity? They're asking how much should be the velocity to pierce a distance of 9 centimeter. They're asking. See, now the kinetic energy done by bullet is equal to work done against the plank, work done against against the react against the Planck's resistance. Now the point is, you will think, what is Planck's resistance? Is the word we see in current electricity. See how much distance it will travel. That's what I'm talking about. See, this is your half m v1 square is equal to how much distance it will go? Force, work done. Work done against this is, see, this is how much force. Force into distance. So force into, say, S1 distance. So this is S1 distance. This is the work done. This is the work done. Actually, work done. Actually, I'm not talking about work done. This all is the nothing against. Wait. Now next one is half mv2 square is equal to, with some different force. This is with F with the same force, and what should be S2. This is S2. Now divide these two equations. So you will get V1 square upon V2 square equal to S1 upon S2. So V1 you know is about 100 meters. So now you can find out. I'm just saying 100 into 100 upon V2 square is equal to S1 is 4. S1 is S1 is 4. S1 is 4 and this is 9. Now you can find V2 from here. You can find V2, do it yourself. Find V2 yourself. Find V2 yourself. Now question number 3. This is question number 2. Wait, no, this is 3, I hope. So this was question number 3, sorry. This was question number 3. This was question number 3. Now let's go to question number 2. Now let's go to question number 2. Question number 2 is, question number 2, here it is. Question number 2 is this. No, not this. Wait a minute. Let me, yes, this. If the linear momentum is increased by 20%, what will be the percentage increase in the kinetic energy of the body? This is question number 2. Now, this can be done very simply. First, understand a very good relation. Question number 2 is very, very important. Kinetic energy is half mv square. Look at this. And momentum is mv. So, in order to write kinetic energy, let's write it k equal to half mv square. So, this can be written as half m v dot v, right? And p is, this is nothing but, this can be written as half pv, or you can do one thing also. This is another way of writing momentum. See, the other way is half m, multiply with an m, make it square and divide with an m. So this becomes mv square becomes p square. Mostly we use this expression. This is why I just told you. We don't use this. You can use this also, but this is of no use here. It is this expression which is a very, very important expression. This is that expression you need. Momentum p square. Now they are saying increase in momentum is 20%. Earlier, this was your initial kinetic energy. Now your final kinetic, see, momentum now has, see, what is the relation now? The momentum has now become 20%. So earlier the momentum was, now p dash is 20% of what it is now, 20 by 100 into this is the increase in momentum. Sorry, this is the increase in momentum, not this, not p dash. This is the increase in momentum, and this is 20% of p. Wait a minute, 20% of p, 20% of p. This is p by 5. So what is del p? Increase final minus initial. Initial is p, and this is p by 5. So p final comes out to be p plus p by 5, that is nothing but 6p by 5, taking an LCM. Now they are asking you increase in kinetic energy delta k dash is nothing but how much it is. K dash is just put in place of p final, you put 6p by 5 whole square upon 2m. This comes out to be around 36, and 25 by 2, this is 25, and this comes out to be half p square by 2m, and this quantity is nothing but k. So this quantity is 36 by 25 k. So k dash is the new k is 36 by 25 times k, the original k. So now how much is the increase in k? How much is the increase in k? Delta k is k dash minus k k dash minus k, that is 36 by 25, k minus k, take the LCM, and this will be around 11 by 25k. So increase in kinetic energy, increase in kinetic energy, increase in kinetic energy, increase in kinetic energy, percentage increase rather. This is delta k by original k into 100. Delta k is how much? 11 by 25 k, k by k into 100. This k and this k cancels out. You get 11 into 4, and this is 44%. This is the amount of increment. This was a good question. Now, the next one, and I think the last one. Let us see what it is saying. What it is trying to say. Yes, a 1 kg mass is connected on a string over this. So see what it is trying to say. What it is trying to say is a mass of 1 kg by a string passing the mass of 2 kg is 3 meter above the floor. Yes, no problem. This is the business. Sorry, this is the business. Yes, let us do it. Question number 1. This is a very good question. See, they are saying this is my pulley. This is my mass 2 kg. This is where whatever it is I think 1 kg. No problem. 1 kg. And this is 3 meters above the floor. The height is 3 meters. The height is 3 meters above the floor. First, I need to find with what acceleration it will come, what will be the velocity, then only I will be able to find the kinetic energy and all that. So, for 2 kg, free body diagram, for 2 kg. 2 kg for free body diagram is 2g, and this is your tension, and this side is your acceleration. And for 1 kg, this is 1g, and 1 kg it is, and this is your tension, and the acceleration is in this direction. So you have t minus sorry you have 2g minus t, excuse me, sorry, 2g minus t. According to the free body diagram, 2g minus t is equal to 2a, and you have t minus g equal to a. So you get g equal to 3a, and a comes out to be g by 3. You get a is g by 3. If the a is g by 3, they are not asking about tension. Don't try to find tension. They're asking you that how much is the gain in the kinetic energy of the system equals the loss of the potential energy of the system. I have showed that. Now acceleration is this g by 3, that is, you can take it around 10 by 3 or 9.8 by 3 meter per second. Do not forget to write this final answers. Now speed, initially it was at a height, at this height, it was initially 0. This was initially 0. Now when it falls down to this height, it has certain velocity. Let's see how much. Use equations of motion which I gave you. V square is equal to u square plus 2as. 2ah you write. V square is, we want to know, u is 0. 2aa is 10 by 3 into how much is the height? Height is 3 meters. So this is around 20 meter, yes, meter per, yes, 20 meter per, sorry, 20 it is. Just a minute, let me write. Meter per second whole square, meter square whole square it is. So now V will be under root of 20 meter per second. This is what you will get. Keep this here. Now the initial kinetic energy of the system. Initial kinetic energy of the system. Kinetic energy initial, Ki. I'm talking about initial. Let's talk about initial. Initially the body, everything was at rest. So half m1 u1 plus half u1 square plus m2 u2, both were at rest. u2 square is all half m1. m1 I think is 2 kg, and 0 is the velocity square plus half m1 kg into 0 square, and then you get a 0. Now finally it gets a velocity of 20 meters per second. Now, and this also rises. See, whatever velocity, see, both have same acceleration. One thing. See, look at this figure. They both have same acceleration. This one as well as this one. They both have same acceleration. They will acquire the same velocity. Both of them will acquire the same final velocity because they are moving together. Because they are moving together. Let me do it for you. See, what I am trying to tell you is, मैं क्या बोलना चाह रहा हूँ? See, initially they both were at rest. So see, now they both were at rest. Now the kinetic energy, see, they suddenly started moving together. They have started moving together. Now the final kinetic energy is K final. They both will now move together. They will both move together with the same velocity, v square plus half m2 v square. Both will move with same velocity as their, now they have the same acceleration. They will move together with the same velocity. Now this is equal to half m1 plus m2 v square. V square we found out, v is, we know that, half 2 plus 1 into 20, because under root of 20, and that is v square, that is 20, and this is nothing but 30 joules of the system. Initially it was joule. Gain in kinetic energy. What is the gain in kinetic energy? Delta K. What is the gain in kinetic energy? That is delta K. This is joules. This is not 5, this is joules. So K, delta K is K final minus K initial, and that is 30 joules minus 0 joules, and this is 30 joules. This is the gain in kinetic energy. Now initial potential energy. Now for finding potential energy, let me take this. Now initial potential energy, initial, that is Ui. Now initially the mass 2 kg is above in 3 meters and 10 mgh, and the 1 kg mass is at height. This is m h. Wait a minute, let me write in mgh format only, otherwise, see, let me write the formula first. M2 mass gh plus m1 gh. M1 is 2 kg, g is 10, h is 3, and m1 is 1 kg. This is 10, and this is 0 height because it is on the ground. So this is 2 3, this is 60 joules. Now the final now when this 2 kg comes down and the 1 kg mass goes up, now the final potential energy. This was potential energy initial. This is initial final potential energy. That is U final. Again, you write the same formula, M2GH plus M1GH. Now what you find is M2 is 2, this is 10, and now the height, because this now reaches ground, and this M1 mass goes up, 1, 10 into 3, this is 30 joules. Now delta U is U final minus U initial. U final is how much? 30 joules. U final is how much? U final is 30 joules, and initial is 60 joules. So you get minus 30 joules. Now see, there was a loss of, therefore, loss of potential energy, and here it was gain in potential energy, in kinetic energy. So gain is compensated by the loss. Even you can use this way of expressing the same thing. Wait, let me tell you. I told you once, wait, just a minute. I told you once that K final plus U final is equal to K initial plus U initial. That means K final minus K initial is equal to plus U final minus U initial is equal to 0. So this is delta K plus delta U equal to 0, implies delta K equal to minus delta U, and you are seeing that only. This is delta K is came out to be 30 joules, and this came out to be minus of 30 joules. Both ways is same. So loss in, basically this is not needed for you. This part is not needed. This I just explained you. मैंने इसलिए समझाया कि whatever was the loss of potential energy was the gain of kinetic energy.